All right, good morning, everybody, and welcome to WESTalks on November 18th, 2021. As always, WESTalks hosted jointly by IC Impacts and the UBC Future Waters Group. The organizing committee, again, as always, Abhishek, Lili, Fuhar, Jaskaran, Kelsey, Furia, and myself. And we've been going for, what's this? We're coming up on, I want to say 18 months. We've been working on this now. So thanks to everyone who's been joining us from the beginning. All right. So as what we try to do at WESTalks is create spaces for global water discussions. And I'll post the link for this global map in the chat in a second. If you haven't added yourself already, please do that. I updated this a couple of days ago. So this is everyone who's ever checked in from a WESTalks seminar. And it's quite amazing to see the global conversations we have and the different perspectives, cultural and academic, that everybody brings from all their unique backgrounds. We've also updated the lineup. So as you know, in September of this year, we switched to every second week. As people were getting back to in-person, we thought that was more manageable. So today we're here with Dr. Ilan Adler from UCL on rainwater harvesting. And then you can see the coming up the list. We'll have 2 more this term into December. And then we'll start up again on January 13th with Dr. Creston Mansfield. And then we'll go, we have speakers scheduled all the way up until June 3rd, I believe is the Thursday. And that's when the West conference is in June. So we have a very exciting and full schedule coming up. And today we're on Dr. Ilan Adler. All of our previous talks are available on the WESTalks YouTube page. So if you just go on YouTube and search WESTalks, or it's on the IC Impacts site, that'll pull up all of the WESTalks previous. Some videos have a whole lot of views, some have less views. So maybe go and check out some of the ones that maybe you haven't seen before or that you weren't there to see. All right, and now on to introducing today's speaker. So Dr. Ilan Adler. He's an associate professor at UCL, University College London, where he did his PhD in rainwater harvesting purification technologies. He's also an enterprise fellow at the Royal Academy of Engineering in the UK. He's founded several social enterprises and charities, including the award-winning International Renewable Resources Institute in Mexico, an NGO which specializes in the appropriate technologies and environmental education, from which a highly successful enterprise, Sistema.bio, emerged in 2008. And that group focuses on an innovative model for small-scale biogas systems, currently with operations across 3 continents. Dr. Adler is also the CEO and founder of Eco-Nomad Solutions, a social enterprise based in the UK, dedicated to improving local conditions for farmers and rural communities through adaptive eco-technologies such as waste to energy or solar-based water treatment systems. And I've seen some news articles about his work there, which is quite exciting. The company was among the first winners of the Shake Climate Change Agritech Accelerator Program, which is jointly sponsored by UCL, Rothamsted Research, Cranfield, and Herefordshire universities. It has since achieved grant funding for numerous projects around the world, including the Innovate UK from Ethiopia, the UCL Grand Challenge for the UK and Mexico, and the European Union. With that, I will stop sharing and we'll hand it over to Ilan for today's presentation.
Okay.
And
I'll
say any questions throughout the presentation, please put them in the chat box. And I think Jaskaran will be moderating questions at the end. Sorry, okay. We're seeing presenter mode. You got to switch the presenter mode again.
Oh, okay. Sorry. We'll get there. Are you seeing it okay now?
Nope, still the wrong one.
Still the wrong
No matter
one.
how many times every week we practice with people, PowerPoint always ends up getting you.
What about now? Still?
Just seeing the PowerPoint now.
Okay.
You do that, and then I think if you click on display settings.
Okay. Sorry, everyone. Just want to say we had it right just a second ago, but. Okay, that should work. Is that right?
Yes, got it.
Okay.
All right, take it away.
Great. We did it. We overcame the technology. So Thank you very much, Carl, and everyone, the West team for inviting me. It's a real honor, actually, and to be speaking virtually from London all the way to Vancouver, which is, quite impressive if you think about it. So you already shared a bit about me and my curriculum. As Carl was saying, I'm based at UCL. I'm the founder of the International Renewable Resources Institute in Mexico, and Economic Solutions in the UK. And I run a number of other projects, research projects linked mostly to University College London these days, where I'm based as an associate professor. So, okay, let's begin and let's hope it all works. Can you hear me okay and see the screen all right? Just to double check.
Yep, all looks good.
You're seeing something that says water problems now, right? Yep. Okay, because I actually have two different screens. So, before we talk about rainwater harvesting, which is a topic that brings us together here today, I think we need to discuss why is that important. So, well, number one is quality drinking water is actually difficult to access, especially in developing countries. Any kinds of water are not that difficult necessarily, depending on where you are. I mean, you can actually access, very contaminated water, wells, rivers, etc. But is it actually water that can be used for potable consumption, etc.? That gets a lot more tricky. So rainwater is actually a very good resource potentially, but also for drinking, not just for non-potable uses or agriculture, etc. But there are quality issues, and a lot of my research, including my own PhD, centered around the quality issues of rainwater harvesting, because just collecting rain from a roof is not that challenging. I mean, let's face it, it's been done forever. We'll talk about that in a few moments. It can be as simple as putting a bucket under a gutter and collecting lots of water. But the issue is, well, how do you store it? How do you actually deal with quality? How do you treat it? How do you install it in a community setting where it's no longer a tap that you open, but you're actually having a community or a household engaging directly with its source of water, and that creates a whole bunch of challenges. So we're going to talk a little bit about the disinfection, the purification of rainwater, which is, like I said, is a bit the angle I've been giving to this for a few years, and the issues around storage, which are quite critical because in many parts of the world, you only have rain 3-4 months a year, like some of the areas I worked in Mexico. And you need to be able to store that for the other 8 months. And that sounds easier said than done. How are you going to conserve it? Are those tanks going to be contaminated? How do you do it in a very cost-effective way to store all this huge amounts of water? So these are some of the problems and the challenges. And I'm going to start talking about Mexico because that's where I started all of these projects about 18, 19 years ago, roughly. And then we'll move on to research and work in other parts of the world, including here in the UK. So number one thing is that, as you can see on this map, rain in Mexico is extremely uneven. The ones in white are basically semi-arid areas. The ones down here, with the lines are, close to rainforest, 1,000, 2,000, 3,000 millimeters, even more around Chiapas. And these are very, very wet areas. So the inequalities in Mexico are not just economic, which are well known. It's a country with one of the highest economic inequalities in the world, probably, in terms of the gap between rich and poor, but they're also present in water. So we have very water poor areas and very water rich. And that's quite interesting because any project you do has to be completely different based on where you are. So I started all this in Mexico City, which is in between the temperate and the rainy zone. Something that a lot of people don't know is that Mexico City receives, even though we associate it with a relatively dry place, it actually receives more rain than London, for example, which to all my students here at the university shocks them because, we tend to think if you're in England, it rains all the time. But it's one thing raining all the time and another is to have storms. And so in Mexico, it's only a few months a year, but it's highly, highly concentrated. And in those few months, you'll probably get more rain than what we get year round with this sort of drizzle that's quite annoying that you get, throughout most of the United Kingdom. So let me share here some interesting slides. Mexico is a city that can be extremely dry. It's very, very water stressed. In fact, I won't go into it today, but I do have a paper. I'll share the publication link later about how water actually gets to Mexico City. And that is actually an incredible feat of engineering. It travels 200, 300 kilometers away. It rises over 1,000 meters. So it goes all over from the lowlands all the way to this very, very high volcanic city. And then it supplies to the 20 to 30 million people who actually live here. So we have to pay a very huge price to get water in, energy price, the cost of actually extracting the water from other regions and other states and so on. And yet, however, you can see this neighborhood, a nice, easy to pronounce name for all of you, Iztapalapa in Mexico City. You can see when it rains, you can easily get floods, people actually moving around on boats. And then I'll show you a pretty shocking image. This is the same neighborhood or close to it in the dry season. So you have people, carrying buckets to their homes, living on 30 liters a day. I'm talking about millions of people, not, 2 or 3 families. Because when you talk about Mexico, the scales are something, hard to get your mind around when you think about a city that has close to 30 million people. So you see people relying on water trucks, on tankers, and there's actual fights in the dry season over who will get the water first. There's corruption to see if you bribe the person who will bring the water truck. And sadly, as happens around the world, the poor people end up paying more. It's the other way around than what common sense would dictate. They actually pay a lot more money per liter of water than what the wealthy people pay, who have tap water and they just get a meter and a bill. The people here will have to pay tons for a truck reaching them. So, of course, when I was working in Mexico City, I thought, well, this is a big disparity. I mean, if you think of, the average consumption per capita, some parts of the world consume a lot more than others. USA, these statistics change. This is quite old, but it still gives you a rough idea that the water consumption is a cultural thing. And it has to do with income level, with historical uses, with technology. There's so many, with political orientations and so on. So you can see Europe has had for a while a more conservative approach to water. The US, this is changing, but still it's probably among the highest water consumer per capita. But look at Mexico City, it's sort of average, but then you have affluent zones with 850 liters a day, areas with private golf courses, swimming pools, etc. And then you have these neighborhoods, which are very extensive, where people will consume about 30 liters an hour a day, which is really not much. If you think a regular toilet is 6 liters and a shower will be about 20, and cooking a bit more, then that's pretty much it. So it's way below the poverty line, according to UNICEF and the World Health Organization, of how much water a human being should actually have to have a decent life. And that even obviously changes if you have dry toilets and so on, but still, that's very little water from whatever angle you look at it. So, of course, if we put 2 and 2 together, which is what I started doing with our NGO there, and it sounded obvious, but it actually wasn't that commonly done in the city, you can say, well, you have lots of water, and then you have a drought. So we could actually bring 2 and 2 together and actually start collecting some of that water. And that's how all my journey started it was around 2003, 2002 with the first systems. But the first thing to note is that we are not in any way original. We didn't reinvent the wheel just because our group decided to collect rainwater. It has been done in the Negev Desert, Petra, fantastic place in Jordan, which is actually in the desert. And they only have about 300 millimeters of rain a year in very concentrated bursts. But the Nabateans, I think it was, a culture who built Petra, they did these settling tanks and channels to actually bring all this water with stone chambers, actually very beautiful ways of storing. The Romans did rainwater harvesting. The Mayas in Mexico had underground rock storage. In India, it was a very old practice as well. But sadly, in the 19th century, with the advent of hydraulic engineering, pumps, et cetera, a lot of that was actually forgotten because it was the trend was more to have big hydraulic works, big piping, big pumps, and so on, and kind of move away from this local, decentralized approach. So it is common to see lots of these cisterns abandoned. And in India, they had the famous tankas, which only have been starting to be revived by NGOs only relatively recently, but a lot of them were actually neglected for many years. So we were thinking, well, this is an ancient practice. Can we bring it more down to the modern world? We see an example here of the 1920s, 30s. Some of you have been to the Park Güell in Barcelona, built by Antonio Gaudí, fantastic architect, of course. And this park was already built, very futuristic. All these columns in the classic Gaudí warp shape would actually have, pipes inside, like they were hollow, some of them, to actually bring the water and collected in massive cisterns underneath the parks. So which was then used in the dry season to keep the whole park irrigated. It's still used. So incredible example of how you can actually make rainwater beautiful and aesthetic as well. So the first project I began was in the university where I was working, which was an American university with a campus in Mexico City. It was called Alliance International University. And basically, it was a very old building from the very early 20th century. Those of you from Mexico or who know the area, it's an area, an era known the Porfiriato from a president called Porfirio Diaz back at the time, who was very inspired on French architecture. So lots of neighborhoods were built with the old French style, including this university. The problem with the French style and with buildings in the early 20th century, there was no criteria about collecting rainwater. This was not the agenda. So the sewage pipes running from toilets, etc., mix with the rain pipes. And that's very, very common. If you go to old buildings, everything is kind of mixed. So we had to actually rescue, in a very old historically listed building, rescue the rainwater pipes. So we had to go as high as we could, break the wall, try to see where the toilets and the kitchens and all that were, or the sinks were connected to this big drainage pipe, and just rescue the rain that came from the roof, and then put purification systems and so on. So that was our first system. It was quite a challenge. We had lots of problems, but we learned a lot, and it was extensively covered by the media and the press, including Reuters. BBC did a program on it in 2004, which really impressed me a lot, because I thought this is the most stupid, silly, obvious thing in the world. We're just putting 2 tanks to bring the water from the roof and bring it down. But you would be surprised at how the resistance there was to it, how little people would do it. And the excuses, the reasons were all sorts of things, from water in Mexico City is contaminated because it's, the air is polluted. Rainwater is dirty, rainwater is wastewater. You don't drink that, you don't want to go near that. There was all these, because of course, when it rains, people see the streets flooding, happens a lot in Mexico City, mixing with the sewage, and they just associate rain with like very dirty water. It's not, the urban association is not this sort of fresh spring and it's a completely different perception, or it was. It's gradually changing, as we'll see. So the success of this led us to build now a new system in the United Nations Environment Program, where I worked as an advisor and consultant for 2 years and managing water programs across the Caribbean and Latin America. The headquarters used to be in Mexico. So we did a nice system that what you see there is actually a sand filter. So I started experimenting with old techniques like biosand filters. Again, nothing new. We're just trying to combine different options. And we were using systems that already existed. Again, old buildings, it's very hard to build new things. So they already had a water cistern. Mexico City suffers from water shortage, so it's common that people will have a cistern anyway. So we just started learning how to purify, filter water, clean it up, and then mix it with rain. That led me to do a massive project, 2004, 2005 as well, with the Ministry of the Environment. That's their headquarters. In Spanish, it's called Semarnat. This was 500,000 liters a year. Big engineering challenge to do this. So we used all the elevated, it's a building that has thousands of people working there. It's the Ministry of the Environment. So we used all the elevated roofs we possibly could. And then an interesting design here was to combine with the existing cistern. Again, they had capacity for also about over 500,000 liters. So what we did is purify the water, state-of-the-art purification, UV, big retro washable carbon filters, particle, everything I could possibly imagine in the book of filtration. I threw it in there because this was a Ministry of the Environment. So they were obviously very concerned with the quality of the water. And this clean water, we would then feed it into their cisterns right here. The not so clean water, because we could separate it into, so the unfiltered, we use it for their gardens. They still have extensive areas. So I set up a couple of taps of just crude, unpurified rainwater. And then we had some electronic controls to kind of know what was going in what direction, how full was each cistern, and so on. That's been a successful design. This is not one of my projects, it was one that I joined up. It was a university in the outsides of Mexico City, the postgraduate school. They had this idea of doing very, very large 1.5 million liter cisterns here with a plastic geomembrane, a brilliant way, which I then adapted to many of my future projects. And then with them, we created something that was called, recall, in Spanish, the acronym is the Network for Rainwater Harvesting. Doesn't really exist in that form or shape today. It's sort of evolved into different things, but it was a successful group. We had NGOs, we had the United Nations Environment Program, we had a couple of universities, suppliers, and it was a nice thing. So this particular group, they did a wonderful project, purify the rainwater. In this case, they used even more purification, reverse osmosis, you name it, and they bottled the rainwater and then sold it to compete with Coca-Cola, who still has a big monopoly over bottled water in many parts of the world, including Mexico. I wouldn't say exclusive monopoly, but I think they take over a huge portion of the market. So this was a cheaper water. It's very soft because rainwater, when you purify, drinking it is lovely because it doesn't have as many minerals. So it's what you call soft water. Some of you will know the difference between hard, which is very mineralized water, lots of calcium, magnesium, and soft water. So this is very soft water. And then I started doing systems in homes as well. And people who shower with purified rainwater, they cannot go back to the other water because it's excellent for your hair. It's, it doesn't clog the sinks, it taps with that lime because it's precisely, it's very soft water. So that has many advantages. So here, again, I learned a lot from this postgraduate school that I showed you. The idea was you can actually build a cistern with this plastic membrane, which is quite cheap. Just put it on the ground, just compact and dig a hole. And then on top, you can put a concrete layer or beam and tiles. There's a few techniques that we can do to just create a slab and cover this. But instead of having a whole bunch of concrete underneath, which is really expensive, it's like building a room underground, we just do this membrane. So after that, I went on to do also not just NGO, but because I had to make a living, right? So I started doing commercial projects. So I did high-rise buildings with big developers. I did the system in the Walmart headquarters for, you have to work with them all, don't you? Which was the main headquarters for Mexico. I don't know if they also control some other areas of Latin America. So their entire building, their new headquarters, I did the full rainwater harvesting system and also advised them on other water saving. They were very keen to get the LEED certification, which is a sustainable building certificate. I work with Holiday Inn, I work with clinics, schools, all sorts of things. So a lot of that is actually summarized in some of these publications I have, but this will be recorded. You can look through them later and maybe find them online or whatever. So I'm going to move on. How are we doing for time, Carl?
We're good. We got another 10, 12 minutes or so.
Fantastic. So that brings us now to new projects that then I started doing and then became the basis for my PhD. So I moved on from Mexico City to other parts of the country. This is a beautiful part of the world, San Miguel de Allende, Mexico, but it's also a very, again, unequal. It's a UNESCO World Heritage listed site. You can go to holidays. It's absolutely beautiful. Many Americans retire there and Canadians. But if you just travel a little bit outside, you're in very, very dismal, poor conditions. So I was hired by the municipality, and we noticed that lots of the schools just did not have any potable water. There had to be a truck delivering water. And what they did have was some wells which are extremely contaminated. So we could see fluoride contamination. We could see arsenic in some of the wells, E. coli. The kids displayed an early disease called dental fluorosis, which happens when you drink water with too much fluoride from the wells, which then becomes a crippling disease for the bones. And we started, they hired me to kind of tackle this problem. And they said, well, let's just collect rain and then purify rain and leave that well water for other uses, toilet flushing and maybe even hand washing, etc. And let's use a clean rainwater for drinking. So the other way around of what most people think. And we started developing this sort of model for rural rainwater harvesting systems. This is based on an NGO that kind of spun out from Erie, from our first group that I mentioned. Very successful. You can look at online, Isla Urbana. The director is actually a cousin of mine. It's all in the family. So it's a very nice graph. You can see here all the elements that you would need to have in a rainwater system. So you have obviously the gutters. I'll show you some pictures. There's a first flush to get rid of the first impurity of the rain. Then you have your cisterns, purification, and so on. And this will change depending on what you want to do. No? And then I'll just show you some examples. So you can actually do very cheap guttering with just PVC pipes cut in half, or you can buy more sophisticated guttering like this with meshes for filters. The first projects I didn't put that mesh, and then we had a bird's nest here on the gutter, unbelievable. And it was just flushing down the whole thing and clogging everything. So our rocks or all sorts of things. So it's important to take care of roofs when you're going to do this. Look into the uses people give. In Mexico, some people hang clothes on the roofs or live there. So you have to consider all of these things. We developed this technique that I mentioned about doing compacted square boxes with membrane, and then putting this technique, which is local in rural Mexico, beam and tiles. And then you could do what I'm showing you on the top right corner. So I did loads of schools and clinics with this technique. Then we started learning from the people who do fish ponds. So I came across them by accident. People, there is this thing called quick tanks. You just have a thin mesh wire here, support a structure, and then you wrap around this membrane, cover it with another piece of geomembrane, and then, voila, you can have a 30,000 liter cistern in a very cheap way, which you can roll up and send to a community. So here we have a settling tank. The water, as you can see, the overflows here first. That's the first dirty water. The overflow goes into our cistern. Besides that, if it's a smaller school, you can also do what you see. This was my partner here, business partner in San Miguel. You can also do them with rigid plastic tanks. So there's all sorts of ways, as you can see here. And this is quite a nice method. Another technique well known is ferrocement. So we work very closely. I'm actually on the advisory board, actually on the board of directors of Caminos de Agua. It's an NGO in San Miguel, and they do these type of cisterns, which look like they're pencil shaped, and they can hold lots of water as well. They are more difficult to install than that, obviously, but they have advantages in that they can be done with local labor. So there's pros and cons, but it's just to give you an idea, there's a wide range of techniques. So what did we do in terms of filtration? So part of my PhD was looking into this thing called silver ionization. So silver is kind of well known. People use it a lot in ceramic filters, colloidal silver, they call it, as a fantastic disinfectant. We developed another technique where you could actually release micro doses of silver into the water, which is actually a lot healthier than chlorine and has a lot less side effects. And it's an excellent disinfectant. At the limits we use it, there's no known harmful side effects, and it also helps, it stays in the water. So remember the challenge we began this lecture with, we need to store the water for a long time. So the idea of having something that has a slight residual, which is not chlorine, because chlorine can create all sorts of problems, react with organic matter, form trihalomethanes and cancerous compounds. We're trying to use this. You can still use chlorine and then filter it out. Here, use chlorine as a pre-treatment. It's another possibility. I work with these silver ionizers, and they were very, very effective. So this is some of the early projects, drinking fountains for the children in the various schools. That's a younger me there inaugurating a project. We work with this NGO Caminos de Agua in very low-cost ceramic water filters. They're actually coated with silver, and they're ceramics, so they help filter 99.9% of bacteria. You can adapt them by using a conventional, super cheap 20-liter jug, put it upside down, put the ceramic filter element, and there you go. I did lots of lab tests on this as well in London, so we did some collaborative projects with them. Now they've evolved, they're a bit more sophisticated, but it's the same concept of a ceramic filter. In the same schools, we also work with hand washing, with dry toilet. This is toilets as they used to be, really disgusting latrines, and we did this nicely well-made dry toilets, also with the rainwater harvesting, which here was used straight for hand washing, because hand washing is crucial to eliminate lots of diseases, not least COVID, but also gastroenteritis, other diseases that kill a lot more people than COVID. So these are some of the communities that I used to work on my PhD. So the idea was, well, how do we learn more about disinfection? So we looked at, reducing various parameters. In this case, it's E. coli, for example. Settling tank, you have a very high contamination. That's the first water from the roof. By the time it gets to the cistern, you eliminated tons thanks to the settling tank. And then the final disinfection will, the ions, whatever, will bring it down to within water quality standards. So Did lots of field work, also beyond the PhD, working with the local environment authorities and water ministry. This is someone from the water authorities of San Miguel as well, and just doing all sorts of monitoring and sampling to actually understand this. Then we've done lots of research. I'm coming towards the end at UCL, where we simulate and model this. A lot of people say, well, what research can you do in rain? You can do a lot. So one interesting thing I did was actually simulate with viruses, because many of these filters that you buy off the shelf, carbon, are great for bacteria, but they're actually not great for viruses, which are very, very tiny. If you see here, a virus can swim right through a lot of conventional filters. So we looked into, again, silver, different disinfection and filtration techniques. And I used something called a bacteriophage, which is a viral indicator. Obviously, I was not going to get an actual real virus, which is super dangerous in lab tests. So you have something called a proxy. So they behave exactly like viruses, but they don't have harm for human beings. But they can help you simulate waterborne viruses, which create loads of problems as well. So we had some interesting results. A lot of that was published in a paper and presented at a conference in Sri Lanka, of all places. And we did learn that the conventional ceramic filters actually don't remove, they do remove bacteria, but not all of the viruses. So you do need to have that extra treatment, be it UV, be it silver or whatever, or even reverse osmosis, which is very fine filtration. Some other research I've done, and I'm still kind of working on, this was also published, is on the life cycle analysis of rainwater harvesting. So this was done with one of my master's students and with a Mexican organization here with CAPSUS. And we picked lots of the buildings where I had done high-rise developments, and we looked at the embodied carbon, and that included to the detail, like the pipes, the concrete, the pumps, all that has an embodied carbon. But we save a lot of carbon because we don't need to pump water from 200 kilometers away, like I explained in the beginning. So it was like learning all the different ways of doing rainwater harvesting. Do you purify it all? Do you keep that separate? Do you just use it for toilets? And modeling that in very sophisticated life cycle analysis software to try to understand the different, impacts that you have on carbon, et cetera, and which is better. So that was quite interesting. And we looked at a lot of, the classic equations. This will all be on the slides that people will use to design these rainwater systems. I'm not going to spend time on equations. I just have them there for the sake of reference. So finally, some other work we've done in London is look at how do we understand these equations, which people use to design, which are very empirical. They're just based on, kind of some rough calculations that you do based on average rainfall. How do we actually have a real life shed, which we set up here, where we control every drop of water that falls, we collect it, and we have ultrasound sensors here that can actually tell us exactly how much water was actually collected, how much was evaporated, how much was lost. Because this sounds a bit getting picky and detailed, but if you think that this can be multiplied over hundreds of thousands of buildings or bigger areas, then this is quite important. These losses are quite important. So we're trying to really understand, and we now move this to a new area, a real-time weather station, and then remote communication to understand and monitor the systems better. That's the latest trend in rainwater harvesting, is try to actually monitor the systems better, because when they fail and they're very far away, you need to send someone, and maybe they won't report it. So having easy, quick indicators using all this great technology we have, Arduino and LoRa, which is a good data transmission protocol, mobile phones, etc., to try to get this data quickly and respond a lot better. So the last bit is just to share some examples. So again, this is Erie Isla Urbana that I already talked about. We worked also with Engineers Without Borders quite a bit. Another nice project done by IRHA, which was collaborated with our NGO, was IRHA's International Rainwater Harvesting Alliance. This was something called Blue Schools, where you integrate sports, arts, other things into the rainwater systems, not just doing ugly systems. This is a beautiful project. I'm very honored to sit on the advisory board of this organization in Madagascar, Tatirano Social Enterprises. It's likely I will be going there next year. We're preparing a few projects with them. So you can see here, right next to the seaside, simple structure built just to collect rain and just falling right in here in a nice ferrocement tank. Again, work in schools, extremely impoverished areas with droughts, with hunger at the moment, but trying to collect all the water that does fall, because there is, when it rains, or as I say, when it rains, it pours, trying to collect it. And this group is also very focused on aesthetics, also like how do you do these systems that look nice? And as you can see, murals and so on, because it's not just, you know, putting a bunch of pipes. It's also how do you make people engage with it, like the children here, you know, relate to it more. We worked a lot with Caminos de Agua, who has taken over all our projects there in this area, with Engineers Without Borders. So we had several years of sending volunteers, working with the communities, doing maintenance, doing upgrading, doing research, building new tanks and so on. As you can see here, the pumps, the filters, the silver ionizers, etc. And overall just working to upgrade all of these systems. So a lot of the stuff I talk about is published. This is just an article on the Mexico City demand management issues. Some things have evolved since then, but it gives you the picture of how a city like that has to actually bring water from really, really far away at an enormous energy expense and carbon expense, because you need to produce all that electricity to pump. And it does propose some guidelines for rainwater harvesting. This other group, Isa Urbana, has done very ambitious programs in the city now. They've installed thousands of domestic rainwater systems, and slowly it's getting there, but still, I would say all of that maybe covers less than 1% of the potential of that city. So with all that, I'm going to end it right here and open for questions. I leave you with a few NGOs, links that you can check later in your own free time. This is where I work, Department of Civil and Environmental Engineering, and that would be it.